All right, good morning, everybody. I hope you are there. Uh, Kim, you can hear me well, right? I can see Kim straight in ports. Okay, guys, let's continue. We were talking about matrices. And in this chapter, we have already covered some special matrices, right? That is equal matrices, row matrices, and column matrices, square matrices, right? And after that, we studied how to add and subtract two matrices. And after that, multiplication of a matrix by a real number. And the last time we practiced multiplication of matrices. Okay. So today in this video, we are going to talk about, in this class, we're going to talk about use of matrices in solving everyday life problems. All right. These problems, you will see that it is a bit long. You have to read with patience, okay? But the solution is, as you see, we are translating these word problems, everyday life problems, into mathematical problem. That means that we are going to express this in terms of using tools in math language, okay? So as multiplication, matrix multiplication follows fixed rules. We have already studied this. Now you should be aware of this and you should know what we're talking about. We can write computer programs to evaluate matrix products of any size, thus saving us many unnecessary hours of laborious calculations. Right? Since actually we're just following fixed rules, almost every software, actually they have this matrix multiplication, or is it tools like MATLAB, for example, any spreadsheet. Even if you just write Google online matrix multiplication, you will see. Okay, so here what we are going to do is we are not going to do this how to do this manually. Okay, here we will try to understand when we multiply two matrices using any laptop or any program, all right, how this thing is done. We try to understand this. And also, maybe in the last 5 minutes or 10 minutes, I will show you how to do these things on Excel, okay? You will see that if you do not have some knowledge about these matrices, even if you have any technology, you will not be able to do these operations. Operations means addition of two matrices, subtraction of two matrices, and the multiplication of a matrix by a real number, or multiplying two matrices together. Okay, let's continue with this example. So example 10, it says that the table shows the results of. Here we have the table. We are talking about this table. Okay, so this table shows, it's a bit, aircon is blowing directly to my head. That's why I'm sweating. Let me put my hat so that I don't get sick. Guys, we are talking about this table. So the table shows the results of, and the bonus points for good sportsmanship to 5 S-League football teams. Okay, so here we are talking about some kind of football league. You may just call this Paragon League, okay? In Paragon League, we have 5 teams, right? They are competing against each other. The first team is All-Star, the second team is Best Form, Champion, Durian, and East Wing. So the first column, it shows the number of plays, how many games played, right? All-Star, they played 20 games, Best Form 19, Champion 21, Durian 18, East Win 22. And here, if they win a match, if any team wins a match, they get how many points? It says a win is awarded 5 points, a draw 2 points, and a loss 1 point, right? And bonus points for good sportsmanship are added to the points gained by the teams. These are the bonus points, right? This is the result. All-Star played 20, 13 of them they won, right? 0 draw, and 7 lost, okay? And also plus bonus points. In similar way, also Best Form played 19 games, right? They won 10 of them and draw 3, right? Lost 6, and bonus points 9. Okay. Now what is the question? Write down 2 matrices only. Write down 2 matrices only. This is important. 2 matrices only, which on multiplication display in their product the total number of points gained by each of the 5 teams. Okay, here we have 5 teams. Now we want to know what is their total score earned in this competition, right? And to do this one, if you do manually, how do you do that? So total number of played, right? Here 20. We have nothing to do with this. No one, 13. For each win, how many points is awarded? 5, right? 5 times 13, right? For example, if I want to calculate this all-star, let's say A, how do you write this? It is 13 times 5 plus, and for draw, how many points? 2 points. Here we have 0 times 2 plus lost. For lost, 1 point. So here 7 times 1. And plus, we just add bonus point, right? It says that bonus points for good sportsmanship are added. It means how actually they performed during the match. And also they got some additional point for their performance. So here I can just write it as, here we have plus, here we have 12. And this 12, actually I should just write only 1 times 12, right? In similar way, if I want to find the total score earned or gained by best form, I should multiply this 10 by 5, 3 by 2, and 6 by 1, and just plus 9. That's 9 times 1, right? So by using matrix multiplication, how can I get the result of these things, right, in one step, with one click, right? To do this one, I need to write 2 matrices. We need to write this in, let's say, in any spreadsheet, and just press enter, we get the result, right? To do this one, you should understand this, how we are multiplying this thing, right? So how can I do this in matrix form? Only for 1. I can write this in this form, right? First, right here, 1, 13, and drawn, it is 0, lost, it is 7, and the bonus points, just I need to multiply this by 1. So here we have 1, right? And here, if I write another matrix, here for win, how many points awarded? 5. For draw, right, the second one, 2 points, right? And loss, it is 1 point. And the bonus point, here just we need to write this thing, right? Here, if we have maybe, I need to write 12 maybe. Here I need to write 1. Okay. So if you multiply these 2 matrices, it gives us this matrix multiplication, right? So that is 5 times 13 plus 2 times 0 plus 1 times 7 plus 1 times 12, right? This is actually in the first lesson, we learn how to multiply row matrix by column matrix. So as you see here, this one is 1 by 4 matrix, and this one is 4 by 1 matrix, right? The result will be 1 by 1 matrix. That result will be the total score of all-star, or total points earned by all-star. Okay, so to do this, what kind of thing I'm going to write? So here I will write this matrix, right? That is our matrix, right? And I need to write here. I need to write here. Here we have 5, 2, and here we have 1, and here we have 1. This is 4 by 1 matrix. Okay, so I should multiply this 5 by this, 2 by this, 1 by this, right? 1 by this. Okay, when you multiply this, here we have 1, 2, 3, 4, 5, right? 1, 2, 3, 4. So here we have 5 by 1 matrix. 5 by 4. Here we have 4 by 1. So the resulting matrix will be 5 by 1. So actually each entry will give us the total score earned by each team. Okay, that is the main idea. Okay, you should understand this, and after that, your multiplication here, that is say A times B, that is our matrix, right? These are the scores earned. I mean, it's about all-star. They won 13 games, draw 0, right? And lost 7, and what is it? Additional bonus point 12. The second team, they won 10 and draw 3, loss 6, and additional point, that is 9. Now, if I write our second matrix, right, this is 5 points for each win, and 2 points for draw, right, 1 point for loss, and additional point as bonus, right? So if you just multiply these two matrices, we will get, because since this one is 5 by 4 matrix, this one is 4 by 1 matrix, the result will be 5 by 1. 1, 2, 3, 4, 5, right? That is 5 by 1 matrix, right? That is the total score earned by each team. Okay. Another example. An OTA factory produces 4 types of seafood OTA. And seafood OTA, I don't know, in Cambodia, have you ever seen this? And I never eat street food. You can see this. Some people actually, they just sell this in stroller, right? So seafood OTA, using some kind of seafoods, they are making food, okay? That is seafood OTA. Especially this quite popular, famous in Malaysia, Singapore, and Indonesia, even in Thailand and Myanmar. Anyway, so there's a kind of food. So an OTA factory produces 4 types of seafood OTA, namely fish, prawn, squid, and mixed seafood OTA. Okay, that is fish OTA, F, prawn OTA, P, squid OTA, S, and mixed seafood OTA, M, for distribution to its 5 outlets. All right, so you are actually producing some kind of foods, and in Phnom Penh you have 5 different brands. Maybe one is in each district. Okay. So you are this every morning you are distributing them, and after that in the evening you are collecting the money. Okay. And also you can just imagine that maybe you have coffee shops, 5 different coffee shops, and you are selling 4 different types of coffee, right? And each day, at the end of the day, you are just collecting the money and evaluating this. Anyway, this is something like this, related to business. So it says that all well receives. That is the name of the first outlet, right? It says that 70 of fish OTA, 120 of prawn, and 90 of squid, and 80 of mixed. And Be Happy receives 120 of fish, 150 of squid, and 140 of mixed. But what is a prawn? They don't receive any prawn OTA, right? Carry On, another branch, receives 150 of prawn, 85 of S, and 60 of M. And Do It Right receives this many. Easy Mart receives this many. Okay, that is given. Now, what is the first question? Before we answer the question, we can just tabulate the given data, right? Now, from the data using this thing, if you just tabulate this, that's the first step. That's also very important. Now, we are going to present our data in tables, right? Which is called tabulation of data. Here we have a data, right? And also in this way, you can actually display this. But as you look at here, we need to read one by one. It's not so clear. But when I display this data in table, right, and reading this data is much, much easier than the previous one. Now, immediately I can see, Be Happy didn't receive any prawn OTA, right? Do It Right received mixed, none. And also Easy Mart received squid, none. Okay. And also from here, all well, fish, 70, 120, 90, 80. That, as you see here, it is more organized and easy to understand. And that's why actually in statistics, or if you're dealing with data, we have to present in such a way that it is easy to understand. Okay. All right. That is what is given. So what is the first question? I cannot see the question. Here is the first question. Okay, because here, as a matrix, I can write it here as A, right? Let's say all the data, it looks like a matrix. Actually, it is a matrix. So let's just name it as, or label this with capital A. So capital A represents this data, okay? All well and blah, blah, blah. Now from here, we can see this is the first row. It's all about all well. This is fish, prawn, squid, and the mixed OTA, right? And this is be happy, throw, and carry on, do it right, and easy mark. All right, now let's answer the first question. Question A. It says that the cost to the outlets of each stick of fish, prawn, squid, and mix is 0.35, 0.40, 0.45, and 0.38 respectively. Why? Because we are selling food, each food has a cost, and here it says that the cost of each F, P, S, and M is given by this. Question, write down two matrices such that the elements of their product under matrix multiplication give the cost of OTAs delivered to each outlet and evaluate this product. Okay, you have distributed everything. Now, what actually we are interested in is, and also the total cost, right? At the end of each day, if you assume that this thing is actually delivered to these shops, if they could sell all the products they have, now we need to collect the revenue, right? So now we need to know total actually from the first outlets, how much should we collect? That's the question. So here, if it's AP, that is OTAs delivered to each shop, right? And this one is individual prices. That is the fish, price of the fish is 0.35. And that is prawn, one prawn, right? That is, I mean, that OTA, 0.40. And this one is squid, that is 0.45. And mix, that is 80, right? When I multiply this, I just bring this, multiply 70 by this, 120 by this, 90 by this, and 80 by this. And you see here, this matrix is 1, 2, 3, 4, 5. It has 5 rows, right? And how many columns? 1, 2, 3, 4. It has 4 columns. And how about here? It has 4 rows, 1 column. It is 4 by 1. So actually, these numbers are the same, right? That means that multiplication is possible. It makes sense. And the resulting matrix will have this dimension, this order. So here I'm going to have 5 rows and 1 column, right? So when you multiply this, I assume that you know how to multiply this using calculator. So 70 times this plus 120 times this plus 90 times this plus 80 times this, and it gives us this amount. That means that outlet A, we need to collect this much amount from outlet A at the end of the day, right? And similar way, if you multiply by the second row, third row, fourth row, and fifth row, we get the second row, third row, fourth row, and fifth row, right? And these are the amounts that we have to collect from each outlet at the end of the day. Okay? Continue. Question B. During the month of December, all will receive 25 such deliveries. Okay? You can just 25 such deliveries. You're delivering this. When they actually run out of the foods, they just give a call and you have to you need to deliver one more time. Okay, anyway, during the month of December, all will receive 45 such deliveries. Be happy, 42 deliveries. Carry on, 38 deliveries. And do it right, 55 deliveries. And easy mark, 52 deliveries, right? And write down two matrices such that the elements of their product give the total number of sticks of OTAs of each type, leaving the factory. Okay, so here write down two matrices such that the elements of their product give the total number of sticks of OTAs of each type. Like during the month of December, let's say the factory produced how many fish OTAs and how many prawn OTAs and how many squid OTAs and how many mixed seafood OTAs. That's the question, number one. Obtain this product and hence find the total number of OTAs supplied by the factory to these outlets. And obtain this product and hence, using this result, find the total number of OTAs supplied by the factory to these outlets. I said the total number all together. That means that the fish plus prawn plus squid plus mixed OTAs all together. How many products they produced? Okay. To do this, that is the quantity, right? And this one is, as you see, 45 deliveries done to the first outlet, 42 to the second outlet. This is what is given in the question. 38 to the third outlet, 55 and 52, right? To the fourth and fifth, respectively. To do this one, if you just pick the first one, right, that is outlet A, because in each delivery, the outlet A received 70 fish otas, 120 prawn otas, 90 squid otas, and 80 mixed seafood otas, right? And if they make 45 such deliveries, what can we do here? I need to multiply 45, right, by this, and by this, and by this, right? To do this one, if you multiply this one, for example, here we have 1 by 5, and here we have 5 by 4, right? 1, 2, 3, 4, 5, 1, 2, 3, 4. 5 rows and 4 columns, right? What do we get here? We have 1 by 4, right? So here we get 1 by 4 matrix, right? And each one gives us the total number of fish and the prawn and squid and the, what is that? Mix. So here we get, let me just delete this, okay? Because first you multiply 70 by this one by this one by this, right? This 0 by this. Second one again, 120 by this, 19 by this, right? And just adding them together. And because we know that the first column, this column gives us all the fish, right? And that's why here it gives us the total number of fish otas produced by the factory, right? Because if you multiply this 45 deliveries to this, so 70 fish delivered to outlet A, how many times? 45 times. 120 fish otas to outlet B, how many times? 42 times. I should multiply this by this. And this, the third outlet didn't receive any fish otas, right? And outlet D, 200 fish otas, how many times? They ordered 55 times. And the last one, if you just add them together, this times this, plus this times this, plus this times this, plus 200 times 55, plus 80 times 52, and add them up, the first entry. What is it? That is total number of fish otas delivered to the outlets. In a similar way, total number of prawn otas, total number of squid otas, and total number of mixed seafood otas. Okay. All right, now the question is total number of otas supplied to the 5 outlets. To do this one, I need to just add them up together, right? I can just add this, but here is the question saying that by writing another one more matrix multiplication. Can you just do this, do the multiplication using matrix multiplication? Okay, so that it gives us the total number of otas supplied to these 5 outlets by the factory. So this one, by what matrix I should multiply this so that it gives us the sum. So I need to write here one more matrix. Okay, this is hypothetical matrix. I'm just making this matrix so that if I multiply this thing by this, it gives us the total. So here we have 1 by 1 matrix, right? And multiply this by 1 times this, plus 1 times this, plus 1 times this, plus 1 times this. So 82,000. That means that during the month of December, the factory produced 82,000 seafood otas. Okay, that's all about this question. All right, gentlemen, let's have one more question, and after that you'll have break. Oh, it's not done yet. So C part, it says that with the information provided in A and B, write down 2 matrices so that the product will give the total revenue derived by the ota factory in the month of December. Okay, write down 2 matrices so that the product will give the total revenue derived by the ota factory in the month of December. How can I do this? To do this one, as you see here, I know I have this matrix, right? And we know the price of fish. They produced this many fish otas, right? And this many prawn otas, this many squid otas, this many mixed seafood otas. So if you multiply this by the individual price, right? A unit price, and also this one by unit cost, and also this one by unit cost, and add them up, we will get the total cost. So to do this one, that is the individual price. That is a price of, what is it? One fish otter, the price of one prawn otter, one squid otter, one mixed squid otter. And in the month of December, they produce this many fish otters, right? And this many prawn otters. And you see here, I'm just changing this matrix. I'm using this matrix, but writing in different form. Actually, in matrix operation, we call this transpose. In Excel, and also you'll see this. So here, we transpose this and multiply by this. Okay, and also in different way I can write this. For example, this one also actually this thing, if you write the original format, right, 1 2 3 4, I can write this price or cost matrix like this, 1 2 3 4. Okay, doesn't matter how you write this, but make sure that it's possible to multiply these matrices and it gives us the total cost. So if you multiply this, the total revenue derived in December by the factory is $32,170. Okay, that's all. All right, guys, have some rest. Next session will continue. Now we have around 7 minutes. Okay, after break, we will see another example. Okay, see you after 10 minutes.